Hello, in this video we're going to talk about object interaction between actors on the board. How an actor like the wombat can know what other actors, in this case ants, are on the board so they can interact with them. Make them turn, make them move, remove them, whatever ant can do. How does the wombat get to know where these things are at and interact with them? So to start off with, let me run this scenario. It's pretty straightforward. It's from the extension from the first couple examples. I have a wombat that moves back and forth, and I have three ants that are moving and turning, so they look like they're circling. All right, and the goal of this is to have the wombat remove these ants. So how does the wombat know how many there are, and how does it gain access to them to remove them? So the class that keeps tracks of all the objects on the board is the world, or in this case our field, a subclass of world. It knows where everything's at. So if I take a look at the world class, if I double click it, I'm taking a look at the API here, or the description of this class. I can see the constructors. I can see all the different methods: act, add object, which we used actually to put our objects on the board, get background, get cell size, height, and whatnot. The one we're interested right now is get objects. What this does is the world goes out and gets all the references to all the objects on our board of in this case, our ant class, and gives me a list of them. So I can then do something with that list. So let me go back to our scenario here, and let's see how we can do that. So I'll go into the wombat class, and every time the wombat moves, I'm going to ask the world, because remember it's a world method, ask the world, or a field, for a list of those ants. And so let's do it. So I'm going to say get world. So this allows me to talk to the world. Get world. Hello world. Can you give me the objects ant.class, all ants? So we know there are three, but let's see that, and actually we'll print this out. System.out.println. Print that out here, and let's compile it. It looks like it's good. So I'm going to ask the world to give me the objects of type ant. So I'll close this, and I'll run it. And off to the side here, in a text box, I can see all the ants. Now what you're seeing here is, oops. What you're seeing here is that there are three ants, and I see an ant, this one, and it's stored in memory at this location. This is a hexadecimal number. It's stored at this location. That's its reference to it. So that's not the most usable thing. So I'm going to go over here to ant real quick and let's maybe print out something a little more reasonable here. I'm going to say public string, two strings. So I'm going to review some strings here, and I'm going to print out or return let's say for an ant, which is an actor, let's get the x coordinate and get the y coordinate. That's a little more descriptive here, and let's run that. And you'll see that I get the x and y coordinates of the ants, which is nice if you want to know where the ant's at. So that's an interesting thing. Let me pause it. Okay. Now, what I just did here was I printed out the list. I didn't actually get a copy of the list so that I can actually access them. I want my wombat to have his or her own list of these ants so that I can use that list to actually access the ants. In this case, I want to remove the ants. So what I need to do is I need to have a instance variable of type list that can hold ant, and I'll call it ant list. Okay, and up here I've actually added the import for list and array list so that you can we can use this. The array list is actually going to be in a constructor. This is a wombat. 1, 2, 3. And what I'm going to do is I'm going to create this list. I'm going to say ant list is equal to a new array list ant. So this array list can hold ants. Here we see list, and here we have array list. We'll talk about the specific differences of that later, but basically an array list is a type of list. So I'm going to create my array list, And now instead of printing it out here, what I'm going to do is I'm going to say my ant list, the wombat's ant list, is going to be, hello world, can you get me the objects of ants? Give me all those objects here. And instead of printing this out, I'm going to just print out the ant list. So I'm going to get the list, store it in here, which means I have my own copy of it as opposed to just printing it out, and then I'll print it out. So it's a slight difference. We're going to see the same output, but there's a conceptual difference here. I'm actually getting my own list. It's like the wombat has his own post-it note. He's getting a list of all the ants that the wombat could then deal with, which will be the next step. Close it, and let's clear this. Recompile. This is get world. Get world. Compile. Looks good. Okay. Compile, and let's run it. And over here, again, you'll see there's no real output, a difference in the output, but there's a conceptual difference. I'm actually getting filling up my array list and printing that out. That's important because let's say I want to then remove an ant. To remove an ant, the world keeps track of that because the world has to know what is and is not in the board, so the world takes care of that. So if I go to world and look here down, let's see, it's reloading. Go down to world, act, add, get this. I can see that there's actually a removed object. As long as I tell it what type of thing to remove, it'll actually remove it. So I'm going to ask the world, we're in the world class again, to remove an object. So let me go back to Greenfoot, wombat, and what I'm going to do is I'm going to say, you know what, world, get world, dot remove object. And what do I want to remove? Well, I'm going to go to the ant list and I'll get the 0th one. So I'm going to say, hey world, can you remove the object? Which one? The 0th one in my ant list. And there are 3, 0, 1, 2. So it's going to remove that one. And if you recall how an array list works, once you remove one, you'll be left with 2. They'll bump down on the list, and then when I remove another one, and so forth, it will get bumped down the list. So if I compile this, no errors, that's good. Okay. Clear this, Control K. And then, now, this is going to be very quick because every time I act, it's actually going to, this wombat is going to get a list of the objects, of the 3 ants. Then it's going to remove the 0th one, so this one will disappear. Then it'll get a list of the remaining 2, because this one's gone, and then remove the 0th one, and then go back again and get another list, which is just the remaining one, and remove it. So I'm not going to run it, I'm just going to act, which just steps it through one time so you can see how it works. So I'm going to click act, and there goes, there's my 3 ants to begin with, but one's gone. So if I act again, you'll see the second one disappeared, and there were 2, now there's 1. And if I click it one more time, it's gone. And I have an out of bounds exception because I'm trying to remove things that aren't there anymore. We'd have to put in some logic with if statements so we don't get this. But you can see how the number of ants is decreasing by 1 because I'm removing them from the list. So in a nutshell, the way I can access objects is to ask the world for all the objects of a given class. And then I stored them in my own list, an array list. Once I have them in an array list, then I can tell the world, hey, remove specific ones. In this case, I was just removing the 0th one. But you can put any logic in there to change any properties, remove, do anything you want with different objects in the list. So, excuse me, that's a quick view of how to access different objects and to start the beginnings of object interaction in Greenfoot.